and the bottom. Okay, so if it's rectangular, basically any surface can be the base, because there's going to be one on the top, one on the bottom, either way. However, if it's triangular, that's not going to be the case. And in example 1, you're going to be able to see that the front and back are actually the bases. Can you guys kind of see that? I wish I had a triangle. It's laid out like this, but it needs to be tipped upward for you to visualize that the bases are the 6x8s and the heights is the 13. Okay? So establishing that, the volume is equivalent to the area of the base multiplied by the height. Triangles are base times height divided by 2. So 6 times 8, which is 48, right? Cut in half is 24. Now they lay it all out for you. They remind you that it's 1/2 of 8 times 6. That's what all those blue numbers are. 1/2, 8, 6. If you want to write it that way, great. In any case, you're going to get to a 24. The height is what? 13. Your volume, in the end, is the product of 24 and 13 in cubic units. Okay, volume is cubic, area, 2-dimensional, squared. Okay? Let's head over to the checkpoint, because they don't give very many examples. Checkpoint 1. This is a rectangular, it is rectangle. Rectangular prism, and it is currently on something that you can see as a base. For checkpoint 1, Jada, checkpoint 1, what would you say the base's measurements are?
8 by 10.
She's right. And we're not cutting it in half because it's not a triangle. So the area of the base is 8 by 10. Did you come up with 80? Lord, I hope so. And since she's identified the 8 by 10 space for you, multiply it by the height, which is what?
3.
Bravo. Did y'all come up with 240, and it's in meters, so it's going to be cubic meters?
Yeah.
That's checkpoint number 1. Checkpoint number 2. I want to draw your attention to checkpoint number 2. Look at it and look at example 1. Checkpoint 2 is sitting on a base. You don't have to tilt it. Okay? So for checkpoint 2, it's sitting on a base. Justice, what are the measurements of the base? For checkpoint 2 on 553. Well, you can give me that, or you can tell me what the 2 measurements are that are going to be 6 by 9. Good. And since it's a triangle, you're going to take that 54 and cut it in half. What do you get? Good. Okay. Because this was a triangle, this is checkpoint 2 on page 553. The base is base times height divided by 2. Multiplied by the height is 4 yards. What'd you guys get? 27 times 4, what'd you guys get? And it's yards, so it's cubic yards. So here are 3 separate examples of volume of prisms. Okay, this one was a triangular prism. This one was rectangular, and this one was triangular. I'm just abbreviating, okay? Example 2 is the exact same type of formula. Okay? Example 2, and this is where we get to cylinders. I like the swimming pool model. I think that's kind of cool. Example 2, swimming pool. The capacity in gallons, we're going to find the volume of the swimming pool to the best of our abilities. And then we're going to actually take it and convert it to gallons, which is a separate thing, but we're going to use the cylinder formula nonetheless. Cylinders are also equivalent to the base's area multiplied by the height. But to find the area of a base of a cylinder, it's pi r squared. Okay? Unlike a polygon, you have to utilize pi. So it's pi r squared multiplied by the height. Now, for the sample they're giving us, the swimming pool. The swimming pool has an 18-foot diameter and a 4-foot height. I'm not going to draw it. So the volume, pi times the radius squared. Kat, what's the radius of this? 9. What's 9 squared? 81. Let's take that radius squared of 81 and multiply it by pi. And I'm a 3.14 person. If you're a pi button person, that's fine. I come up with 254 as my base area. 254 as my base area. Now they left pi out, which kind of bugs me. .254 times the height, which is 4. Now this is actual volume, folks. They don't. I'll show you what they did here in a minute. 254 times 4 is what, about 1016? And it's cubic feet, right? Look at what they have, 3.324 times pi, and if you multiply it, you get 1017 using the pi button. Okay, so we got the actual volume. They left it as pi. Okay, which kind of bugs me that they did it that way. This is the actual volume. 1016 feet cubed. This is easier than what they did. Multiplied by 7.481 gallons per feet cubed. Will give us the actual number of gallons required to fill this pool up. 1016 times 7.481. And I came up with 7601. They came up with 7614. Not that much different. They used the pi button. I used 3.14. Now you're saying, that's a lot of gallons, Mrs. Myers, but because I didn't use the pi button from the beginning on my calculator has a different starting point, so each time I utilize that number, it's a little bit off. Okay? But for your purposes, this is good enough. Okay? This is good enough. If you come up with something in the 7,600 range, a little high, a little low, I would be okay with that. Okay? What they did, if you look at their thing, 553, they did 324 times pi times 7.481. We already did 324 times pi right here. We saved ourselves that extra step. We simply solved it. We didn't leave pi as a symbol. We solved it. Okay? So approximately 7601 on the gallons. They've got 7615. Let's flip. Checkpoint 3. No worries. This is another cylinder. With a radius of 5 and a height of 15. The circles are the bases. You can picture that by tilting it up. This is a can on its side. The volume is going to be the area of the base, which is pi r squared, multiplied by the height, which we already know is 15. Okay, if I tilt it up like this, I can better recognize what my base is. I tilted it up right. Pi times 25 25 times. What do you guys get? 25 times pi. What'd you get, Tiana?
Let's try the opposite.
And I use my pi button. You use your pi button? Yeah, I got that too. 79. Multiply by 15. Ethan, finish it off for me.
15?
That's the height.
11,178.09.
So 1178. That is correct. Okay. Area of the base multiplied by the height, just like in the rectangular and triangular prisms. Okay. Rectangular, triangular, and cylinders. The formula is the same. Volume is equal to area of base multiplied by the height of the object that's being solved. That's all we do. Okay? All right. In the interest of time, I'll give you the rest of this period to go ahead and get started. We do have chapel today.